Okay, hello, this is Dr. James, and today I'm going to show you how to build a Nernst lamp. Look at that. It's lit. Oh, it's so amazing. No vacuum seal around it or anything. Just lit up in the air. Look at that. Okay, hello, this is Dr. James, and today we're going to do part 3 of our Nernst lamp experiment. Trying to build a Nernst lamp. Very interesting device. It uses a zirconium oxide rod, which I actually melted in the last experiment because I didn't, I just wanted to test it for the temperature, see if the tungsten could hold up to the temperature, because I was using copper before that and the copper melted because it got really hot. And so I didn't have any protection in the circuit. Basically, it's kind of a negative resistive runaway type curve, because the hotter the zirconium gets, so the zirconium doesn't conduct electricity at room temperature, so you got to heat it up. But the hotter it gets, the more it conducts electricity. The more it conducts electricity, if you got a high voltage on it, it's going to get hotter and it's going to run away. It's going to be like a nuclear meltdown. I don't know if you can see, but it actually melted. The zirconium rod is bent. Zirconium oxide is really got really hot. And so I'm going to try to, and I think I blew out the fuse on my voltmeter, unfortunately. Let's see, where is it? Still haven't fixed that yet. Let's use a different voltmeter now. Blew out the fuse on that guy. I'm going to have to take it all apart to find it, because it's not under the battery compartment holder. So we're going to try to limit the current with some really high power resistors. These are some wire wound resistors, and I have a tap here, and we can go down to pretty low resistance. The resistance is going to, remember, this has a positive resistance, so it will limit the other one's kind of a negative, but it depends on the temperature. You know, the more current you put into it, the hotter it gets, the lower the impedance is, and so it will run away. And so if we put a positive resistance IV curve, have a slope like this, it will stop the runaway, hopefully. And I'm going to start with a high resistance, and it may not ignite at a very high resistance because it may not be enough electricity to keep it hot. But we'll start high, and then we'll work our way lower and try to find a good sweet spot for this thing to operate at. And then we should be finished with the basic experiments of how to build a Nernst lamp. Some technology that's been lost for probably 100 years. Very cool, huh? Anyway, let's get going. Okay, so here we have a super high power resistor, and I'm just checking the resistance. It has a tap in the middle that you can move, so you can, the whole resistor is a kilo ohm, but the tap is about in the middle, and it looks like that is about 400 ohms. Okay, so we have about 400 ohms across there, and let's see if we do the math. Let's see, 100 ohms, we'll say 120 ohms out of 120 volts would give you 1 amp. So this is going to be like maybe about a quarter of an amp. So I don't know if that's going to be enough current to sustain the burning of our Nernst lamp, but it'll be an interesting starting point. So maybe we'll start here, and then we'll try some different impedances, and we'll go down to as low as we can on this one possibly, and then maybe we'll try going to some other resistors that have lower values. Okay, should be interesting. Okay, so here we have our big ass resistor and our hooked up. Let's check the circuit. It comes from the wall. One side goes to the Nernst lamp, through the filament, through the tap, through the resistor, and returns. And I have the power turned off up here. So let me turn the power on. Okay, so no explosion there. And here we have our torch going. Let's see if we can get this to ignite. Under that type of load. Okay. Get the torch a little bit hotter. to self-sustain under that resistance. Okay. Well, it looked like it was kind of flickering, but it may be too high of a resistance still. So remember, we had this thing taken off and going way too hot before. See, look at that. I can see some flickering in there, like it's starting to maybe light up. But you see that right in the edge over here, the right hand side? There's some light inside the zirconium. Okay. And this is a little bit over 400 ohms. And get a little bit hotter with the torch. Okay. See, it looks like it's starting to maybe self-sustain. It's doing some weirdness there. Let me change the tap on the resistor. I'm going to bring the resistance down, and we'll try it at a lower resistance. I'm going to turn the power off first before I fiddle with that. See, the red light's on. That means the power's on that. Okay. Okay, so I loosened the tap on this resistor, and I kind of have to hold it with my finger now to get a resistance reading. And so if we slide this tap down, I'm going to slide it down a little bit here. That's about 300. I'm going to slide it, okay, 200. Let's try it at about here, maybe 200, and we'll see what kind of behavior we get out of it. I'm going to tighten this tap back up here, and yeah, so that's around 200 right there. Okay, so about half the impedance. So it should be about 4 times the power if I'm doing my calculations properly. Okay. Okay, so again, here I move the tap down so it's about at 200 ohms, making sure nothing's touching that's not supposed to touch. And we'll turn on the power again. Okay, our power's on. And I have my torch running. So we'll try heating her up and see what happens. Okay. So we have everything hooked up right. Right, complete circuit. See, I think I had the torch a little bit hotter before. Okay, let's try this. Okay. I don't know. Okay. Well, it looks like it's still not self-sustaining, but it's kind of flickering. It's got that weird flickering thing going on. Okay, so maybe I'll decrease the impedance even more. Maybe try going down to 100 ohms or lower and see what happens. Okay. Make sure the power's back off. Okay, so here we go. I adjusted the tap again, and so now we're close to 100 ohms on that guy. And I'll stick this back into the circuit and we'll see what happens. Should be interesting. Okay, so we have the 100 ohms back in the circuit. I believe the circuit's set up properly. Out of the wall, through the filament, through the clip lead, through the tap, through the resistor, and back to the wall. Let's turn our power back on. Okay. And we got our torch. And we'll heat this guy up. See, I'm seeing flickering on the ends. Looks like I see electrical discharge in there. Ooh, shit. Looks like our zirconium rod melted in half. So let me just try to turn off the electricity and I'll reseat that, put half of it back in there. And we'll just run with half the rod. Okay. Okay, I have the electricity off and I disconnected part of the circuit. And we'll just see if we can see how hot this is. Gosh, the tungsten's a little bit warm still. Oh, come on, really? Seems to be stuck in there. I'm gonna have to fiddle with this. Okay. Come on. Oh, there we go. Oh. Okay. So let me put a different section of the tungsten, or the zirconium rod in between the tungsten holders, and we'll try it again at this impedance and see what happens. Okay, so I've just slid a different section of that zirconium rod through there, so we have a fresh section in there. I've hooked the circuit back up, and we'll turn the voltage back on over here. The red light's on, and we got our torch going. Oops, we don't have our torch going. We can put it out. Okay, and let's try heating up this section and see if it will light. Under its own power. Oh, look at that. Seemed like it kind of wanted to stay lit. I can see light on the back side of it flickering too. See that? There's light. It's like some kind of sparks or something going into it. So you can see little flickers of light around the edges of it. See that? Looks like it's trying to stay lit, but I still think the impedance is a little bit too high. Maybe I'll try to see if I can bring it down to 50 ohms and see what happens. Okay, so I guess this thing wants to beep once it gets down to about 50 ohms. So here is our resistor, and we're measuring the impedance, and it's down to 50 ohms. So we'll try this one. I'm going to tighten this up and try it there. Okay? Okay, so here we have our experiment again, and I have the tap set at about 50 ohms. And making sure it's not shorting at the top, because that thing is pretty teetery. Turn on the power. Okay, our light is on. Our power is on. Our torch is on. Turn the torch up a little bit. Okay. Oh, look at that. It's lit. Okay, so this is 50 ohms. Wow. Oh, is that amazing? Oh, I see sparks coming off of it. See that? There's little sparks coming off of it. Staying lit all by itself. 50 ohms here. Okay, so there's the magic impedance. Look at that, isn't that beautiful? Oh, that is amazing. Oh, look at that, here we go. There's my Nernst Lamp. See if I can get us both in frame. It's lit. Oh, it's so amazing. No vacuum seal around it or anything. Just lit up in the air. Look at that. Oops, what happened? I don't know, something happened. Oh, I think the zirconium, it finally went out. It's running for several minutes with the 50 ohm load. And it looks like it started evaporating the zirconium onto everything. And I don't know what happened, but it seemed to have gone out. You know what? Why not? Let's see if we can light her back up again. I don't know if the impedance changed because of that or what, but let's give it a shot, see what happens if we heat it back up. Let me get the torch a little bit hotter. Okay. Oh, there we go. It's lit back up again. Oh, isn't that so beautiful? Look at that. And there's little sparks coming off of it. I'm not sure if I like that. If you can see those little sparks coming off of it or not, but it's pretty bright. See those? Look at that. It's shooting little sparks out. Oh, how amazing. So it just went out a second ago all by itself, so I don't know. It just lost momentum, if it's barely, you know. Wow. Oh, I guess the filament burnt out. Okay, so anyway, we didn't start a major fire there, but looks like the filament burnt out, completely melted between the two contacts. Okay, so I think that's the end of our experiment. Okay. Anyway. Okay, so it looks like that little filament kind of burnt away. It was pretty hot. It burnt right through the piece of paper that it dropped on, and then it scorched the table there. Here it is. About the same shape and size of that. Unbelievable. So, okay, so that was a new piece of filament. It seems to have melted. And I'm not sure how to fix that problem. But very cool, huh? I think the original Nernst Lamp were a combination of zirconium oxide and yttrium oxide. Maybe there's a reason why they did that. Maybe it has a higher melting temperature or something, but it's... Anyway. Ooh, was it starting to melt my clip leads too? Or was that from before? I don't know. Anyway. Very cool experiment, huh? And a success. Definitely a success. Self-lighting Nernst Lamp. Okay. This is Dr. Janes, and thanks for watching. Ooh, I'm seeing bright spots in my eyes.